Hello geometry students. We are going to start today by going over that last example that you had to do in the video and a few other extra examples. So we're going to start with extra example number 1, which is on the bottom of page 17. It says, is triangle DEF or triangle to GHJ similar to triangle ABC? Right now I want you to take out your packet, turn to page 17 and go over these with me. If you got the answers wrong, please make sure you fix them. So the question is asking, which triangle is similar to ABC? So I'm going to have to answer two questions. I'm going to have to answer, is DEF similar to ABC? And then I need to know, is GHJ similar to triangle ABC? Starting with the first one. My sides on DEF are 6, 9, and 12. So I wrote small, medium, large. On ABC, my smallest side is 8, my medium side is 12, and my largest side is 16. So, if my triangles are similar, these three proportions will be equal, or these three ratios will be equal. So let's see if they are. 6 over 8 simplifies to 3 over 4, 9 over 12 simplifies to 3 over 4, and 12 over 16 simplifies to 3 over 4. Okay, so all of my ratios are equal. So we would say, yes, triangle DEF is similar to triangle ABC. We would say by SSS similarity. Please remember to put the tilde so I know that we're talking about similarity and not congruency. Now you need to do the same thing with triangle GHJ. Triangle GHJ, my smallest side is 8, my medium side is 10, and my largest side is 16. Now again, going back to ABC, I have sides of 8, 12, and 16. Now you should notice right away that these are not going to be equal. 8 over 8 is 1, 16 over 16 is 1, but 10 over 12 is definitely not 1. So all of my ratios are not equal, so we would say no. Triangle GHJ, if you put the tilde and then a slash, means not similar, so GHJ is not similar to triangle ABC. Okay, so hopefully you got that one right. If not, you're going to have a few more examples to do in class today like that, but you need to make sure that you checked both similarities. So the question was saying, which triangle is similar to ABC? So you need to check both. Okay, so right now I want you to flip to the next page so we can do a few more examples together. So example number 2, it says find the value of x that makes ABC similar to triangle DEF. Okay, so right now you're going to notice we have two triangles with a whole bunch of sides. Anytime that you have sides, it's really good to start out with the triangle with the statement of proportionality. So looking at this, I know that AB is going to correspond to DE, and I know that BC is going to correspond to EF, and lastly I know that AC will correspond to DF. Now what I'm going to do is I'm going to fill in all of those sides with their actual measures. So AB is actually 4, DE is actually 12, BC is x minus 1, EF is 18, AC is 8, and then DF is 3 times x plus 1. Okay. So we don't know the value of x. X can be any value that it wants, but we want to find the one value of x that will make our triangle similar. Now, if our triangles are similar, this statement of proportionality has to hold true. So I want to make this statement true. So I'm going to start with these two ratios right here. Now I'm going to start with those because the ratio on the left, I have both of the numbers, and then the ratio on the right has an x. So up here, that gives me 4 over 12 equals x minus 1 over 18. And I'm going to do cross products. Now 4 times 18 is 72. And then I get 12x minus 12. Because you have to remember to multiply the 12 and the negative 1. If I add 12, I get 84 equals 12x. Dividing by 12, I get x equals 7. Okay, so right now it appears that if x is 7, my triangles are going to be similar. So let's plug that in and make sure that that actually works. So 4 over 12 stays. 7 minus 1 will give me 6 over 18. And then I get 3 times 8, which is 24. Now, 4 over 12 simplifies to 1/3, 6 over 18 simplifies to 1/3, and 8 over 24 simplifies to 1/3. Okay, so what we just showed here is if x is 7, my triangles are similar by SSS. All the sides are proportional. Now, if x is 8, that's possible, but the triangles won't be similar. So when x is 7, my triangles will be similar. And then we have a few more examples. It says, tell which method you would use to show that the triangles are similar. So as a reminder, the first method that we learned was AA similarity. And then in last night's video, you learned SSS and SAS similarity. Looking at example 3, I have two sides and nothing else. So this looks like it could be SSS and it could be SAS. But I'm going to need more information. So is there anything true about the figure that's not marked? Well, I should be able to tell that these are vertical angles. Because I now have angles, I'm looking at SAS. I have two pairs of sides, and I have the included angles. Now, the sides need to be proportional, so I need to check that. On my left triangle, or the triangle on the left, I have sides of 9 and 18. The triangle on the right has sides of 15 and 30. 15 is the smaller side, so that goes with the 9, and 30 is the larger side, so that goes with the 18. Okay, I need to know, are these ratios equal? Well, 9 and 15 are both divisible by 3, which gives me 3 over 5. 18 and 30 are both divisible by 6, which gives me 3 over 5 also. So, I can say that my triangles are similar by SAS similarity. But I do want you to write the similarity statement. So I'm going to go triangle ACD is similar to. Now if I go ACD, that's big side, vertical angle, and then small side. So big side would be DC to my vertical angle, and then E to my smaller angle, or my smaller side. Okay, example number 4. Tell what method you would use to show that the triangles are similar. In example 4, all we have are a whole bunch of sides. So it looks like we might be using SSS. Now they don't tell us in example 4, but they don't tell us what triangles we're looking at. But we actually have 3 sets of triangles. We have triangle 1 on the left, we have triangle 2 on the right, and we have the entire big triangle. So let's look at triangle 1 and triangle 2. Triangle 1 has sides of 12, 16, and 20. My triangle on the right, so triangle number 2, has sides of 9, 12, and 15. So this is going to simplify to 4/3, 4/3, and 4/3. So I know that triangles 1 and 2 are similar. So triangle 1, I'm going to call triangle XZW. When I do that, I went small, medium, large. So I would have to go YZX. Okay, now I'm going to compare triangle 1 to my big triangle. So triangle 1 still has sides of 12, 16, and 20. By big triangle, I mean this triangle right here. Sorry, poor choice of color. Okay, so the smallest side on that triangle is going to be 15. The medium side is going to be 20. And this is going to be my largest side right here, which is going to be 25. Now, this simplifies to 4 over 5, 4 over 5, and 4 over 5. So I also know that triangle 1, so my triangle XZW, is going to be similar to the big triangle. So when I wrote XZW, that went small, medium, large side. So for the big triangle, that would be YXW. Now, I have XZW is similar to 2 triangles. That means, by the transitive property, that these 2 triangles are similar to each other as well. So really this gives me triangle XZW is similar to triangle YZX, which is also similar to YXW. So in reality, the triangle on the left, the triangle on the right, and the big triangle are all similar. Okay, one more. Example number 5. So right now I have a pair of angles congruent, so these right angles right here, and I have two pairs of sides. So it looks like it might be SAS. Now, I said this in the video, but I'm going to say it again. You can't just say there's two pairs of sides and a pair of angles, so it's SAS. You actually need to check that the sides are proportional. The triangle on the left has sides of 24 and 28. The triangle on the right has 18 and 21. 18 is the smaller one, and 21 is the bigger side. Now, 24 over 18, I can divide both of those by 6, and I get 4 over 3. 28 over 21, I can divide both by 7, and I get 4 over 3. Okay, so I have two pairs of sides that are proportional, and I have a pair of congruent angles. So we would say that triangle SRT is similar to, SRT goes small, medium, big side. So small, medium, big side. So triangle PNQ, we would say by SAS similarity. Okay, so in today's classwork, when it asks you, are the triangles similar, yes or no, you need to show work so that I understand why SAS is true or why SSS is true or why no is true. Today, you will be doing the classwork on pages 21, 22, and 23. For some of the tougher problems, I have started the problems with you in a video, so I've given you some hints that are posted on Schoology. All the answers to today's classwork are posted on Schoology, and all of the video hints for the more difficult problems are on Schoology. So if you get stuck, go to Schoology, watch one of the hints, and see if that helps you. Due tomorrow is today's classwork and What's Wrong Wednesday. Good luck!